to write this down. But synthetic division only works when you're dividing by a linear term. Do you know what a linear term is? It's going to be something that makes a line when you were to if you were to graph it, right? So if you divide by like x plus 2, or if you divide by 2x plus 4, okay? If you divide by something like that, then you can do this type of division, the synthetic division. If not, you just can't do it. So I will only give you situations where you can do it, but just a heads up, that's the only situation that you can do it in. Okay, so synthetic division. Instead of setting it up like this, we flip it over. And what happens is we do a bar like this, but we're going to fit 2 sets of numbers in there, so make it plenty tall, okay? And now we are going to lay it out. Just like yesterday, you need every number of, like your exponents have to go in decreasing values still, right? So x to the 4th, then you need an x to the 3rd, an x to the 2nd, and an x to the 1st, and then your constant, okay? So what we do here, and I'm gonna color code for you a little bit just so you can see where I'm at. You're gonna take all the coefficients of your first polynomial. So you're gonna take the 3 and put it here. You're gonna take the -4 and put it here. You're gonna take the 2 and put it here. And you're gonna take the -1 and put it there. Okay. Another way that synthetic division is opposite of what you're used to is now before we would just take this x minus 2 and we would drop it out in front. Instead now, we're gonna take the opposite. We're gonna take what would make it a 0, okay? What number would make that a 0? A +2, right? So if it's x minus 2, you're putting a +2 out in front, okay? Okay. Are you ready to do some synthetic division? Here's your steps. The first thing you're gonna do is you're gonna drop down that first number. So in this case, you're gonna drop down the 3 and you're gonna put it right here, okay? The next thing you're gonna do is you're gonna multiply that number by our number out in front, that 2. So 3 times 2 is 6. I'm gonna put that right here. Okay, so 3 times 2 is 6. And now, again, completely opposite of what we did yesterday. Yesterday, when we put something underneath a number, then we subtracted, right? Today, we add. It's always addition with synthetic division. Okay, so every time these are gonna be added. So you're gonna go -4 plus 6 is what? 2. Now you're gonna do the same thing again. You're gonna take this 2 up here and this 2 down here, and you're gonna multiply them to get a 4, and then you're gonna add them together. 2 plus 4 is 6, okay? Your last one, 2 times 6 is 12. And now here you're gonna put this little bracket because this is actually gonna be your remainder in the problem, okay? So you put the little bracket there, you add them together, -1 plus 12 is 11. And now what happens is you have a polynomial. You don't see the polynomial yet, but this is gonna be a polynomial. This blank right before your remainder is always your constant. The one next to that is always your linear term. That's the one that's just gonna have an x to the first power, right? That's linear. And then the one in front of that is gonna be your quadratic. Okay, so if there was one in front of that, it'd be your what? Cubic, 3, right? And then quartic, and then quintic. So it's just your exponents. This is a constant, so x to the 0 power is 1. This is going to have an x attached to it. This is going to have an x squared attached to it. And you would just keep working your way over. So when you write this as a polynomial, it's going to look like this. 3, actually, let me keep with the colors so I'm not confusing. So it's 3x squared plus 2x plus 6 remainder 11. Okay, or if you like it the other way, 3x squared plus 2x plus 6 plus 11 over, and we started with the x minus 2. So if you want to write it that way, you can write it that way. That's really up to you. Okay, either one of those is a great answer. Questions on that? Yeah. Oh, shoot. Hold on. So it's just based on, this is our remainder, and then everything in front of that goes in increasing order if you work from right to left. We want it in decreasing order from left to right, right? So this is the one that's not going to have an x attached to it at all. Then it'll be x to the first, and then x to the second, and then x to the third, and x to the fourth, the further you go from your remainder. Does that make sense?
Yeah.
Okay. Okay, questions on that?
What
Johnny.
if it has like a cubic number in the front of the equation?
Like if it has this in front here?
No, if it has like a 4x cube, not cube.
Oh, to the fourth?
So yeah, to the fourth.
Yeah, you would just keep going. Like if you end up with, so whatever you end up with here, if there is one number, it's a constant. It's the number 6. If there's 2 numbers, that's your x and your constant. If there's 3 numbers, it's x squared, x, and your constant. If there's 4 numbers there, then you would do x to the third, x squared, x. So you're always doing descending order of your variables, exponents.
So if there's 4 there, the one in front would be
X to the third.
Okay.
Yeah. So it's always one less than the number that it is, I guess you would say, if you're working from your remainder side. That's a weird way to say it, but yeah. I'll show you again with this one, and hopefully that'll make a little more sense. Okay, look at this one. What do you notice? Notice something.
There's no 2x.
There's no x squared, right? So you're going to set up your bracket. What's your first number that you're going to write? A 1, okay? This would be a 1. And then there's a 0x squared there, right? We don't have an x squared, so the number you write in for that is 0. If you need to see that, it's this. X cubed plus 0x squared minus 13x plus 12, right? That's what we're starting with. So a 1 for this guy, a 0 for this guy. So what would come next? Negative 13, and then positive 12. Okay, what do we put out in front here? A negative 4. You put the opposite of what you see in your binomial. Okay, so if it's x plus 4, we're going to call that a negative 4. Do you add or subtract with these? Add. Every single time you will add. Okay, so what's your first step? Drop the 1 down. So 1's going to go here. What do you do next? Multiply. Yes, negative 4 times 1 is a negative 4. Add those together, you get negative 4. Negative 4 times negative 4 is a positive 16. Add those together, you get what? 3. And then here's where your remainder comes in, this fun little bracket. Negative 4 times 3 is a negative 12. Add those together, you get 0. So there's no remainder on this one. Remember, this is your constant term. So this is the one that's not going to have an x. This is your linear term. This is your quadratic term. So it's going to be 1x squared, or just x squared, minus 4x plus 3. And there is no remainder. You don't need to write remainder 0. You can just leave it just like that. Okay, when there's no remainder, that's the best setup. Questions on that? Okay, you try C. Try that one on your own. It's written slightly differently. It's the same idea, right? You're still going to start with your bracket. You're going to fill in your numbers. There's no missing numbers on this one. Work that out. See what you get. And if you get a really high remainder, it's okay. It is a really high remainder.
Can you go up real quick?
Yes. Yes. So much ma'am today. I feel so respected and old, but whatever. So first thing you do here is what? God bless. Drop down the 5. 3 times 5 is 15. Remember, you're adding. -6 plus 15 is a positive 9. 3 times 9 is 27. Add those together. 27 plus 4 is 31. 3 times 31 is 93. Add those together, you get 92. So this is going to be 5x squared plus 9x plus 31, remainder 92. Or, if you like it the other way, oops. You may write it as 92 over x minus 3 added to the end of that. Either one of those. Questions on that? Okay, so that's synthetic division. The next thing they're going to ask you to do with it, and here's where it's really important that you pay attention to what they're asking you to do. If they say divide, then just divide and give me the polynomial. But if it says factor completely, you're going to divide, and then you need to factor it to come up with your zeros from this. So, okay, this one, if we set it up, you have, I'm going to move quickly through the division part because I feel like we've got a decent handle on this now. So you put in all your numbers, you put in your -2 out in front, we are adding. You're going to drop down that 1. -2 times 1 is a -2. Add those together. -2 plus -2 is a -4. Multiply those, you get a positive 8. Add those together, you get a positive 3. -2 times 3 is a -6. Add those together, you get 0. So we end up with the polynomial x squared minus 4x plus 3. Okay, now here's what I want you to think about. We divided, right? We said this divided by this equals that. Yeah.
I understand how to do it, but how did you, because didn't we multiply on the last one? For the,
Multiply where?
when you, on the last one, like when you dropped like the 1 down, don't you multiply by -4? And like this one?
You multiply it by this,
Yeah.
right? Yeah, so -2 times 1, and you put that
Oh,
here.
You multiply for everyone? I just got confused.
Yeah, so you're going to multiply, you add them here, which gets you this, and then you multiply those two, which puts you here.
You always add, right?
You always add, but then you multiply, so you'll always multiply with the number under the bar, and you'll always add the numbers above the bar. Does that make sense?
Yeah.
Okay, anyway, so here's what I need you to understand about this. If we divided these two things and we got this, that means that the product of those two things would get us this polynomial, right? So essentially right now, having factored so far, we're saying this times x plus 2, right, times this will get us that. This says factor it completely. So what can you do to keep factoring?
Do it again.
Star method, right? This can be factored further. If I do the star method here, I have what can you multiply to get 3 that you can add to get -4. That's going to be a -3 and a -1. So that means I have x minus 3, x minus 1, and that x plus 2 that we started with. I think that's what a lot of people forget about, is that one that we started with is a factor of our polynomial. So this is what we get. In order to do this factor completely thing, you always need a remainder of 0, right? Otherwise, you wouldn't be able to factor it completely. So just a heads up, if you get to this point and you have a remainder, you did something wrong when it says factor completely, okay? So we have this. What would the zeros of this be? Yes, okay, your zeros, your x values would be 3, 1, and -2 if we were solving that polynomial, okay, or that division problem. Yeah, Kate.
So that's the answer, the 3, 1, and -2?
I want to see this. I want to see that you factored it completely. That's factoring it completely. But then to solve it would be 3, 1, and -2. So you can give me both of those things. I'm trying to think in the book. They might just ask for, let me check real fast. Okay, this next 2 problems here, we are going to evaluate, but you cannot use your calculator for this, okay? You have to do the division. I need to see the work of how you got your answer. If you plug this into your calculator and you give me a number, you'll get 1 of the 3 points for this. You have to show me the long division, okay? Show me what you did. So here's the deal. When they say evaluate what P of -4 is, basically what they're saying is if you're dividing by something, we would say it's like we divided by x plus 4, right? P of -4 means x plus 4 is a factor, okay? So your remainder is actually your answer to this problem. So just keep in mind when they say evaluate and they give you a P of something, you are finding the remainder. Your answer is the remainder, okay? So P of -4, you are going to set this up just like we set all the rest of them up. Okay, this is gonna be, oh, what is this gonna be? What are your numbers? 1, 0. Yes, this is x to the 4th plus 0x cubed, right? There's no x cubed there, so you have to make it a 0. Then you can do the -5, the +4, and the 12. Okay, now here's the thing. When it's P of -4, they've already done the work for you. This was the factor. It's the opposite. So when it's P of something, you put that exact something in the division spot. You put the -4 there because the factor was x plus 4, okay, when they say P of -4. As essentially they're saying evaluate it for this 0, okay? So if this is our setup, we're still gonna add. Bring down your 1. -4 times 1 is a -4. 0 plus -4 is -4. -4 times -4 is a +16. Good morning. And then add those together. Thank you. -5 plus 16, what do you get? 11, right? -4 times 11 is a -44. Add those together. You get a -40, and then don't forget, this is your remainder, and that's what we're looking for here. You don't even have to write a polynomial from this. You just need the remainder. -4 times a -40 is 160. What's your remainder? 172, okay? So when they say evaluate P of -4, your answer is 172. Your remainder is always your answer. You don't need to write this as a polynomial. Leave that stuff alone. We only want the remainder, okay? Okay, so you try the last one. The nice thing is all your numbers stayed the same at the top, right? Yep. What'd you get?
48.
Got 16.
Anybody else get 16?
Yeah.
It was 16. Okay, so you're putting a positive 2 here, right? Because this is a positive 2. Bring the 1 down. 1 times 2 is 2. Add them together. 0 plus 2 is 2. 2 times 2 is 4. That gets you a -1. 2 times -1 is -2. 4 plus -2 is 2. 2 times 2 is 4. Add those together. 12 plus 4 is 16. Did you multiply them? Yeah. P of 2 then is 16. Okay, so just find the remainder when it says evaluate P of something. Okay? Questions on that?